Hi, this is Shivani, and today I'm going to be presenting my FYP topic, which is music visualization using deep learning. So, to give a little bit of background, I'll be talking about what exactly music visualization is. It can be classified into two forms, which are structured and unstructured form. So, structured form refers to the arrangement or density of notes, and unstructured form usually refers to the musical fragments or elements. Linear form and spiral form are examples of structured form, whereas paintings are example of unstructured form. So as you can see in the linear form, this is basically a visualization of how the notes fall in the piano in a particular time frame. And for the unstructured form, this is basically an example of a Kandinsky painting where he painted whatever he heard in that song. So to give a little literature review, I'm going to be talking about existing methods. So, firstly, this is a technique developed by Stanford scientists to automate the process of sheet music where it identifies the notes in a given time. So, as it can be seen, this is an example of a structured form of music. So, this is neural synesthesia, which is basically an unstructured dynamic representation of the music where the image changes based on the musical elements such as density and the pitch of the audio. So the main gap in this is that there's lack of research done on producing a static unstructured form using AI. As AI is a developing field, there's still more room for improvement. So my main objective for this project is to use deep learning techniques to produce an unstructured form as well as a static image as the final output. So my brief approach would be to basically have an input using Spotify and prepare the data set, finally produce the abstract output. I'd be taking I'd be explaining about a brief steps of each step. So firstly for the input, a Spotify URI is retrieved from the chosen track by the user. So the user selects a song from Spotify and then the library extracts audio features such as energy, tempo, and mode. These are the values crucial for the sentiment of the song. So as you can see in that picture, the Spotify track number is basically the URI, and the sentiment value is the sentiment value of the given song. So in this example, Beethoven's Moonlight Sonata was used for this. Next, for the clustering of the dataset, the main aspects to determine the sentiment of the picture was found to be number of colors, colors present, brightness, saturation, and contrast. So to cluster the dataset, the k-means clustering was used and the elbow method was used to decide the value for k, which was found to be 20. So the pictures are two such examples of clusters. So the picture on the right is the cluster 7 and on the left it's cluster 10. So as you can see, the images in the picture are basically similar to each other. So moving on to matching the song to the corresponding data set, we need to first find the sentiment of the data set, which is the sentiment of each cluster. So the main algorithm for this is to identify the colors present in the picture along with its breakdown of percentage in the picture. This is then multiplied to give the sentiment for each color and finally summed up to give the sentiment of the entire picture. So the song is then matched to the cluster based on the similarity value to the nearby clusters. So there can be a matching of more than one cluster for this. So for the example of Moonlight Sonata, the song was basically matched to cluster 4 in this. Moving on to produce the final visual output, the chosen clusters are then trained using StyleGAN2 and image augmentation is done to increase the number of images. This is then trained using Google Colab's GPU and the final output images are produced. So in the example of Moonlight Sonata, the final image produced was this picture. But the number of output image can be increased based on the user specification. So this is an example of 4 output images produced because the user can specify how many images they want to be produced. This is to ensure that different interpretations are kept in mind when producing an abstract output. So to conclude, my approach was then verified using the user study to confirm that it corresponds to different interpretations of the same piece of music. The final idea is to create an art music gallery with the picture representation and the music playing in the background. It was also verified that it produced both a visually pleasing and an informative image. This basically opens up new perspectives on different interpretations of music as it finally produces an abstract image. I would like to thank my supervisor, Associate Professor Alexei Surin, who helped me throughout this process. Thank you.